Hello, everyone. Welcome to the session. Will be led by Alexander Statnikov. He's the head of data science, machine learning, and automation at Square. Please join me in welcoming him to the virtual stage. All right.
Hello, everyone. Good afternoon. Really excited to give this presentation and grateful to organizers for giving me this opportunity. So I'm going to present an algorithm for growing data science teams and tech capabilities. So first of all, I want to briefly give a little bit of highlights of my background. So I've been in the field for over 20 years, and I had a mix of academic and industry background, and my latest jobs in the industry were in American Express, SoFi, and Square, where I'm currently now. So this being said, I want to highlight a little bit about the setting with respect to this talk, so where this algorithm is used. So the setting specifically is the following, that you are landing on a job in data science machine learning leadership. Your new company is really thirsty to implement data science and machine learning models to grow the business. There is an existing data science team that worked really hard to lay out foundations and get the company excited about unlimited opportunities. And your job is now to take the team and capabilities to the next level and deliver value to the business. And what is really your algorithm for success? And this is what we are going to talk today. So I outlined the algorithm here. It has a number of steps, and I'll be sharing slides later. They should be linked in the deal room, or I'll give my email so that you can send me inquiry for the slides. I'll gladly share. So briefly, on the high level, the algorithm consists of the people stack algorithm and the tech stack algorithm. And we will go step by step to understand exactly how it works. So first step of the people stack algorithm is that you need to learn about the existing team, company, and business. So this requires developing understanding of team's work and pain points, learning about systems and how they are connected and how they are used. You should not be underestimating complexity of the business. You need to learn about company's culture and processes, and whatever you will learn in this step, it's not enough. And as you can see on top of this page, there is a very well-known Dunning-Kruger effect, and it shows you need to really recognize whether you are at the peak of stupidity, value of despair, slope of enlightenment, or plateau of sustainability. And as you learn more, as your confidence changes, that's where you're progressing. So first thing is really need to learn and to reflect on your learning abilities. Next step is you need to build partnership with stakeholders and core functions. So for this, you need to identify current and future business stakeholders, prioritize them, and learn about their KPIs. Partnering with technology, human resources, and financial functions is really essential. And it's important to engage and show your genuine interest, enthusiasm, and invest your time and actively listen. I showed below this small chart that shows there is a business value versus readiness. And it's often the case that the risk function is really ready. It has pretty significant business value. Marketing may have even a stronger business value. For some use cases, they may not be as ready as risk. And other functions, this is my personal reflections, they may have less business value or high business value, but their readiness is quite different. And this helps you to really prioritize the partnerships as you advance in your future role. Next step is to win the team over. And winning current team is really key, even if you are critical about talents or ability to deliver. And as I showed on the diagram below, it's critical to win the team because the core of the data science in the company is about domain expertise. And even if you may be able to get in the future people with greater mathematical abilities or computing skills, domain expertise, it's very important. And most likely your experts who know best the domain are already in the company, and you really need to utilize them for the journey. You need to be intentionally biased towards perspectives of the team. It always helps. You have to learn from team and take their side. You need to show that you are truly caring on people and you need to lean on people. And finally, being open to feedback. So these are a few components for this step. Then you need to think through and identify what is the optimal organization structure that you're willing to adopt. You should not be biased towards a particular organization structure. Every company has their own needs and they also change over time. In general, centralized teams, they help to establish the culture within the profession and also achieve amazing foundational results. Decentralized teams can be better aligned with stakeholders and can have a deeper vertical expertise, which is also critical. And there are a lot of hybrid models that are even more popular than a pure centralized and decentralized. You can see below several graphs which I borrowed from this article about setup of the centralized team, hybrid team, and decentralized. And there's quite a bit of literature which is worthwhile to review to identify the optimal org structure that discusses pros and cons. Next step is really to develop and refine career ladders. It's important to adapt industry career tracks and keep up with changes because they're also evolving. And tracks depend on industry, state of the business, company, and business needs in general. Even if you are talking about the track for data scientists, machine learning, depending on all these factors, they may be quite different. Common tracks differentiate analysts, modelers, data engineers, and infrastructure systems engineers. And it's also often helpful to have a separate track, one for technical, for experts, and the other one is for people leaders. And I put on the right visualization of a commonly accepted expert track or technical track when somebody starts as an entry-level IC, then becomes IC, strong IC, raises as a technical leader, becomes solid technical leader, senior leader, and then goes further in the company, industry leader, and somebody who can really create the industry, somebody who can really define direction of the industry with respect to machine learning. Next step is once you have career tracks in place and you know the optimal org structure is really reorganizing the team that enables to increase business results and position team for growth. My personal perspective, it's important to engage the team into defining the new org and seek how the feedback, because data scientists have millions of options. And I just did a quick search on a variety of websites. LinkedIn simply hired Indeed. And as you can see, the number of opportunities which are currently open for data scientists just in San Francisco, I'm not talking globally for US, is in thousands. So you have to really value the team and take them for the journey. As a part of reorganization, it's important to consider how you can convert friction into collaboration. And it's also very important to be empathetic for people who do not fit in the new org and find a way how you can make these people successful and put your personal time on this. And remember, there is no perfect organization. Organizations evolve. Next step is focusing on recruiting top talent. You need to lean on your team and human resources. You need to be cognizant about bringing your prior colleagues. It may not be perceived really well, even if they are the best people. You need to find the right time and right format. You need to engage personally in interviewing, regardless of how high up you are. It's always helpful to expand panels to include members of your team, not only stakeholders. And bringing team to interviewing their manager is also one very important tactic. Obviously, we have to seek buy-in from stakeholders and ensure that first foremost, new talent can fit in the culture and can maintain great working relations. And one insight I also want to share on this page, based on my experience in recruiting, that it's much harder to recruit experienced analysts than data scientists or people who have a lot of deep technical modeling skills. So even though the data scientists and machine learning modelers can be more well thought opportunities, hiring analysts is much harder. Next step it's about execution and focusing on driving key business KPIs. Obviously, it requires alignment with business KPIs, focusing on addressing technical debt, which is both essential for the business and important for the team. It's another critical step. You need to establish best prioritization practices and lean on professionals, for example, product managers, rather than reinventing the discipline and doing it yourself. And I showed a quick diagram that summarizes product management. And this is very important learning, that as you're building the team, it's important to bring diverse set of professionals rather staffing only data scientists, because product managers can be really force multipliers for the whole effort. And finally, it's important to make execution organized and provide visibility of progress and milestones to the stakeholders. Moving on, next step, number 9, it's about continuously recognizing the team and investing time in their development, because team needs to know that their effort is worthwhile and they move closer towards solving key problems step by step. I personally think it's important to recognize both effort and results. It's important also to create plenty of opportunities for both technical and leadership development of the team. And I showed at the bottom just a few websites with a bunch of courses in data science, machine learning, that it's important to encourage the team to take and to create opportunities in their day-to-day work to do so. And finally, remember that this step, the recognition of the team and investment in their development, is essential to defining team culture, productivity in the team, and ultimately your success as a leader. Next step, it's about iteration, because the previous steps, they may not come in an exact sequence, and it's important to iterate through them. You have to be flexible, open to changes, adopt a growth mindset, allocating your efforts proportionally with the areas of opportunity. It's another recommendations. Working towards creating an autonomous team and growing leaders who can eventually take a role and be more effective in doing it. So this is really one of the really keys to mastering the people stack algorithm. So next comes the technology stack. So once the organization is in place and you think they can be set up to succeed in data science and AI, now we really need to think through whether they have essential technological capabilities. And here is a process which I abstracted as a 4-step process. It can be more complex. So first step is really learning about current stack and historical context. You have to dig deep to understand how and why current technological stack operates. You need to understand the purpose of each component and underlying architecture principles. It's very important. And as you can see here in this graphs, which is a great article published in Towards Data Science, it's called Architecture for High Throughput, Low Latency, Big Data Pipeline on Cloud. There are different ways how you can implement this architecture end-to-end. And there are great diagrams that are published that show how to do it on clouds. So again, assessing stack end-to-end, it's very important, from data capture, really how you collect the data, to decision-making that comes about the presentation or a specific inference or running the models. You need to pay particular attention to compliance, privacy, and security. Sometimes there are great stacks which you can adopt, but it will not work in the current setting for a number of reasons. And finally, it's important to seek divergent perspectives from your team and outside the team about the stack. Next step, it's about developing strategy for enhancing your stack. So it's important to focus both on near-term and on long-term. Obviously, one component of success here is making explicit connection to the business problems and KPIs. Near-term should be making things operational and steps towards doing things right. And long-term should be the state where everything works great and there is flexibility to address future changes and adopt new technology as they evolve. It's very important to bring team and company in this exercise. So this is co-owned. A part of this process, it's also important to engage with cloud providers, vendors, consultants, experts, everybody who can offer help and advice in this journey. And a common gap in many technological stacks today is a feature store. And here is one diagram which I borrowed from the web that explains what the feature store is. And this is my recommendation to companies who are looking at the technology stack for AI and ML, is to assess what is the adequacy of their feature store, what it is, and how it's needed. Next step is identifying means to execute this strategy. Again, this is something that is connected with the people stack, as you will see. In general, you have to be flexible on means to achieve your goals. And besides human resources, you need to consider third-party tools and subscriptions, and also importance of organizational structure outside of your team, which can make things much more efficient or inefficient to advance with your technological strategy. Alignment with company KPIs will help to find means to execute it clearly, and you need to be prepared to run one or few pilots before getting leadership on board and allocating further resources. And one insight I have to give here, which is connected with the people stack, it's that there is incredible variety of human resources which you can bring on board to enable execution. It's employees on your team, employees on other team, contractors, consultants, interns, externs, partnership with academia, which can come as capstone projects and public competitions. And even if you are hearing that you don't get in more headcount, you don't get more ML scientists or engineers, there are a lot of other means how you can get things done and advance your technological stack. And finally, the next step, it's about executing and continuously engaging data scientists and business customers when you are building the stack on them. You have to stay on top of execution, be agile. Engagement of customers early on and keeping them through the journey is important. It's about seeking their feedback. You need to reiterate connection with the core business KPIs and report how they increased, even indirectly, which is often the case for the foundational capabilities. Reporting milestones and arranging roadshows is also key to success. And finally, the key here is about clearly communicating significance of progress and results. And this image below shows the data scientist or engineer and the business user on the right. And it's important to recognize that there is an invisible wall or visible wall between these two. And it's important to put an extra effort to ensure that the communication works effectively. And there is a great translation from both sides. So this concludes the core part of my talk. So thank you so much. I'm open for questions. Here are my 2 email addresses. I'll be glad to share the presentation if it's not accessible from the deal room. And I also want to advertise amazing career opportunities of Square, where I'm really grateful belonging to. And you can check roles which are posted online on our careers website. So thank you so much. And I will now be taking questions from the chat. So what are the one of the questions that comes across is what are some best practices in building and growing a feature store? So there are a lot of great best practices. They have to deal with what are the requirements for your company. Do you need to execute it? What does the real time mean? For example, how many models you need to support, and what is the complexity of the data that you have to deal with. So I think that it's there are not so many really established best practices, I would say, because it's a pretty early field, but there are great websites and forums that provide the examples of industry-leading feature stores, which can give idea of the requirements. Next question about the guidelines of processing, labeling data and ensuring the accuracy. So this is a great question because often when we are doing data science, we don't have enough labeled data and how we go about labeling data. So there are different crowdsourcing capabilities which people can use. It depends on the security and compliance of the data. Sometimes you may decide to keep this data in-house, not engage a third-party labeler. And another important consideration is also the amount of expertise needed for labeling. There are also machine learning solutions that help with labeling, that help to use techniques such as active learning to iterate on the gold standards. And in general, you need to consider all of this, both machine learning solutions, then using crowdsourcing, and take into consideration compliance and security. So a little bit on the feature store, there is one more question. The importance of the feature store really is that we have foundational data, the enterprise data, which is stored in the databases. And in order to deploy the model, we generally need to get a subset of elements from these databases and pass this data through the ETL, extract, transform, and load processes. And the feature store provides the environment where one can ensure that this transformation can be readily applied, and they would be representing directly the data that is used for training the model. So it's a very convenient means to encode and represent and deploy the features so that the model can run on them in real time without having multiple complicated ETL processes that may be going through data warehouse and other data environments. So there is a question about the trusted data fabric. I'm not sure I fully understand this question, but I guess it goes about the trust in the underlying data. And it's my suggestion, my experience, that it's very difficult to fully trust the data, and it's you may be stuck thinking about the quality of the data. It's important to also bring very strongly the dimension of the business problem that you are trying to solve, and thinking about the trust of the outcome, in addition to thinking about the trust in the input data. So because sometimes the data may not be perfectly trustworthy, but the outcome can be adequate to answer the question. So with respect to, there is a question about the financial services and regulatory scrutiny. So this is a great question because there is a lot of governance that is implied by regulatory scrutiny. There is a Fair Credit Act. There are a lot of other regulations. Some of them mandate using only specific types of features for solving specific problems, such as credit, to avoid discrimination. And there are a lot of considerations. Risk management and big financial services institutions have already solved this problem and constantly also evolving and iterating on their solutions. And it's important to bring compliance and also build automated solutions so that it's easy for compliance to identify which features can be used, and at the same time also assess for biases in the data. I think we are finishing in about 45 seconds. I'll be glad to take one more question if there are any more questions. Again, the presentation most likely will be accessed from the deal room, which is linked to the abstract. If you don't see this, you can just send me an email. I'll be gladly share the presentation. So thank you so much. Really appreciate everybody's time, and feel free to reach out to me. Thank you.